I'm sure we humans are all familiar with the term of sacrificing ourselves for our own family. But what about in the animal kingdom? Red squirrels are a non-social mammal species and have been known to adopt closely related juveniles and raise them as their own. Hamilton's rule is that altruism should occur when the fitness cost to the actor is less than the fitness benefit to the recipient, which is then multiplied by the coefficient of relatedness. This means that in the case of the red squirrels, the surrogate dam adopting an orphan juvenile is only likely when the juvenile and surrogate are closely related to each other. The authors of the paper conducted a study over 19 years in which 5 occurrences of close kin adoption occurred, with among a total of 2,230 litters. The ancestry of both the surrogate dam and the adopted juvenile was known. All 5 of the adoptions occurred within different years and had different surrogate dams and juveniles. 4 of the adoptions were discovered by observing the individuals which had unique ear tags both nursing and nesting with the surrogate dam and her offspring. The 5th adoption was discovered when the field technicians entered a nest and found a juvenile that was significantly larger than its littermates. It was discovered that the large juvenile was from a neighbouring litter. This discovery was confirmed by collecting tissue samples from both of the litters. Identical genotypes were detected between the neighbouring litter and the larger juvenile, which proved that the dam had in fact adopted the juvenile from the neighbouring litter. An estimation of the minimum relatedness of the squirrels was made using the maternal pedigree as shown. Non-kin is defined as being related less than 0.125. The maternal pedigree confirmed that in the 5th case of adoption, the juvenile and surrogate dam were non-uterine siblings. It was found that in 29 additional litters, the dam died and there was surrogate available, however no adoption took place. Only 2 of these 29 cases had neighbouring kin females which could adopt the orphan litters. This resulted in a strong relationship between the adoption and kinship. A surrogate dam adopting additional juveniles decreases her fitness altogether, as an increased litter size means that she has less survival of her own litter. Using Hamilton's rule, it was found that in the 5 cases of adoption, the surrogate dams were related to the adopted juvenile, to increase their inclusive fitness. However, in the 2 cases where the kin female did not adopt, the adoption would have caused the female to have reduced inclusive fitness. The solid line on the graph represents the fitness cost of adoption to the dam, while the dashed line represents the benefit to the adopted juvenile, which decreases with litter size. The 5 adoptions are represented by closed circles and result in increased inclusive fitness. The unadopted litters are represented by open circles and would have resulted in decreased overall fitness. Adoptions by red squirrels show a form of altruism that follows Hamilton's rule. Even though the females could have adopted unrelated juveniles, they never did so, which provides a clear test of Hamilton's rule. Hamilton's Rule and the Causes of Social Evolution is an updated paper which is based on the concept of Hamilton's Rule. It provides evidence for Hamilton's Rule by presenting novel synthesis of results from 2 kinds of study in diverse taxa.